Hello, Big Reds. This is Mr. Official talking to you here. This is going to be the Unit 3 review video for the Unit 3 test. So we're going to start off with this problem right here. First of all, you're going to need a sheet of graph paper and a sheet of regular line paper would be great. So some things you're going to be asked, first of all, AB, what's the length from A to B of this triangle? So it's 1, 2, 3, 4. There are 4 spaces. This also goes from the point 3, 1 to the point 3, 1, 2, 3, 4. No, I'm sorry. Goes from point 3, 1 to 3, 1, 2, 3, 4, 5. So if you look here, there are 4 spaces, and the distance between 1 and 5 is also 4. So AB is going to be 4. This length is going to be 4. B to C, you can see this point is point 3, 1. This is point C is the point 4, 5, 6, 6, 1. So you can see the x values change by 3. There are 3 spaces. So BC is going to be 3. You see, this has a length of 4, this has a length of 3. Now, just like we did in Unit 1, when a line is on a slant like this, we're going to use Pythagorean theorem, because this is a right triangle, points to hypotenuse. We're going to use 3 squared plus 4 squared equals c squared. Right? And we take 3 squared is 9, 4 squared is 16. We add these numbers together, and you get 25 equals c squared. Take the square root, get c is equal to 5. So that means length of AC is 5. We could put that right here. Now, to get perimeter is when you add up all the lengths of the sides. I'm going to add up all of these 3 right here. So this is going to take 4 plus 3 plus 5, which is 12 units. Okay. And the area is going to be 1/2, or base times height divided by 2. In this case, the base is 3, height is 4, so we take 3 times 4 divided by 2. That gives you 6 square units. Okay, so right here, this is 5 out of 20 points on the test so far. Okay, next, we're going to talk about a few triangles here. Get out a sheet of blank paper like this would be fine. So I want to classify a triangle. If I have a triangle, all of its sides congruent, let's say this is 5, this is 5, and this is 5, that's called an equilateral triangle. Because equal means they're all the same length, lateral means sides. So the sides are all the same length. That's what equilateral triangle means. If I have something like an isosceles triangle, though, something like, let's say this. If the base angles are congruent, these sides are going to be congruent. So let's say I'm going to label this A, B, C, and let's say BC is equal to 10, AB is equal to 3x plus 2, and AC is equal to 4x minus 5. Okay? So what would we do to solve this? Well, since this is an isosceles triangle, isosceles triangle, if the base angles are congruent, these sides are congruent as well. So these two are going to be equal to each other. So I'd take 3x plus 2 equals 4x minus 5. Subtract 3x from each side, and I end up with 2 equals x minus 5. Now to solve this, add 5 to each side. So we get x equals 7. So 7 would be what you're solving for here. Now, let's say I want to solve for something like AB. So I want to know, what is AB equal to? Well, AB, as we see up here, is equal to 3x plus 2. Now I know what x is. I could take this 7 and plug it in for x here. So AB is actually equal to 3 times 7 plus 2, or AB is equal to 3 times 7 is 21 plus 2 is 23 units. All right, that's what you have so far. All right, now I want to talk about congruent triangles. As you know, there are 5 ways to prove triangles congruent. There's side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Now, if you ever have 2 triangles, for instance, both have a right triangle, that doesn't guarantee that they're congruent. Okay, that doesn't guarantee that it's HL, because we know HL is just for right triangles. But if the right angles point to a side and these sides are congruent, hypotenuse is congruent, and then of course the side in the middle that they both share is congruent, this would be an example of HL for congruent triangles. Okay? So this is very important. The right angle, the points on the right angles must point to the hypotenuse, always point to the hypotenuse. If the hypotenuses are congruent and the leg in the middle is congruent, then it's congruent by HL. But again, what they point to has to have a mark on it. That's important. Okay? Now, if we had something like this, again, don't go by what mine look like, go by the markings. That's important. So this is A, B, C, D, E, F. So if I have, let's say, A is congruent to F, E is congruent to C, and let's say CB is congruent to DE right here, like this. Okay, these two would be congruent by angle, angle, side. And to write a congruent statement, we would write triangle ABC is congruent to triangle. Now it's important you match up corresponding angles. So A and F have the same markings. So F would be first. B doesn't have any markings, so that would be same spot as D. And C has 2 markings, E has 2 markings, so those would be congruent. So when you write a congruent statement, make sure all those corresponding parts match up. Okay, next, I'll flip over the paper. Now, if I have something like this, okay? Obviously, these 2 triangles are congruent by side, side, side. And if I have this is X, and this is 7, and this is 10, what would X be equal to? Well, X has to equal 10 because these have the same marks. Okay? All right. Right now I'm going to take a pause and we're going to transition to video number 2. So this is going to be the end of video number 1. Please make sure you watch video number 2 as well.